Hi, and welcome to Allen High School's discussion of bonding at the APIB HL1 level. We are in the midst of talking about the different types of bonding and models for bonding, and we are now discussing covalent bonding. So we're looking at our covalent compounds, inorganic in particular. Organic is carbon-based, inorganic is pretty much the rest. Now, molecular formulas, unlike what we had for ionic or our network covalent or our metallic, molecular formulas actually have a discrete formula with a precise number of atoms. And the molecular formula tells us the actual number of atoms that are bonded to one another. Now, what they don't tell us, that's valuable, that's what we would use in a balanced equation, but what they don't tell us is how the atoms are bonded. What do they look like in the 3D world? What's their structure? So we want to build into some sort of structural model. And to help us with that, we have our Lewis dot structures. We don't usually draw Lewis dot structures as if they're 3D structures, but they do lead us to an understanding of the three-dimensional shape of a molecule. And here are the steps that we saw when we had pre-AP, maybe a few variations on a theme. You count up the number of valence electrons, add or subtract the number of electrons due to a charge. If it's a negative charge, you add. If it's a positive charge, you subtract. The element with the lowest electronegativity is typically the central atom. There's a few exceptions. Hydrogen can never be a central atom, for example, even if it's the lower electronegativity. Typically, it's the element that's written first, is the central atom. Then you surround the central atom with your peripherals. We call them the peripheral atoms, the ones that go around the side. We're going to use two dots to represent a bond. If you want to use lines for bonds, that's fine. I don't allow you to use lines for non-bonded electrons, but in place of those two electrons, you can use a line as long as we're talking about a bond. Now, this next step your teacher may have done different. I satisfy the central atom. You can certainly satisfy the peripherals if you want. The reason I do the central atom is I tend to think of the central atom as the mama, right? Mama kind of takes care of everything, doles everything out, so everything's fair and even. So if we are deficient, if we give all the electrons to mama, satisfy her first, kind of like on an airplane where they say that the adult's supposed to put the oxygen mask on first so that the adult is then able to help the child. That's why I do the central atom. If we're deficient, mama will give us more electrons. If we have extra, we're going to let mama hang on to those extra electrons. I think you'll see as we build some more up. Satisfy an octet. There are a few elements that are exceptions to the octet, and that's shown in this rule here. Fluorine and hydrogen only form one bond, but fluorine still has an octet. Oxygen can form only two bonds. Boron forms three bonds. Okay, so we've got hydrogen is satisfied with two electrons or one bond. Beryllium, because it's so tiny, likes to play in the covalent world, and when it does, it forms two bonds or four electrons. And boron is okay with 6 electrons and 3 bonds. It'll do a fourth, and we'll talk about that later on, but by and large, it's okay if you just give it 6 electrons. It's pretty tiny. It's happy with that. Okay, let's see how we did these. This is a little small, but you have them in your paper. We have the 4 electrons. Carbon gives us 4. Each hydrogen brings 1. I get 7 from that chlorine, and so I have a total of 14 electrons. Okay, and how I like to do it, you set your central one. Carbon, we're going to put in the center because it's less electronegative than chlorine, and hydrogen can't be in the center. Do you notice I make my bonds? Once I've made my bonds, I've used up 8 of my electrons. I now have 6 electrons to use. Recall that hydrogens can have only 2 electrons. So, and the carbon is satisfied. Carbon has 8, so it's satisfied. So I'm going to give those 2, 4, 6 electrons, and you do it kind of in a 2 for you, 2 for me. We're going to do it pairs at a time. So now my chlorine is also satisfied with 8. Notice that bonded pair gets to count for both atoms that are on either side of the bond. All right, let's do this phosphate. Phosphorus has 5 electrons. I have 4 oxygens. They each bring 6. Now, phosphate, if you remember your polyatomic rules, if you don't, 3 negative charge means 3 extra electrons. So I have 32 electrons. Now, we're going to use the rules to predict phosphate. I'm going to tell you this is not exactly what phosphate is. It does something unexpected and not predicted, and we're not going to go there right now. So we're going to do it as if this little process works quite well. So phosphorus is my least electronegative, so I put it in the center. I use 80 electrons to make my bonds, and I would do them 2 at a time. 2, 4, 6, 8. Okay? I've used 8 electrons, so I have 24 left. Okay? Phosphorus has 8, so it's satisfied. I go around my oxygens. Everything's satisfied. You notice that all the oxygens have 8, and the phosphorus has 8. Now, remember from our previous video that you need brackets and you must indicate the charge because it's covalent within. So these are covalent bonds, but it does have the ability to ionically bond to an ion, such as the aluminum ion. So polyatomics can have both covalent and possibility ionic bonds. Okay, the next example just shows the 3 H pluses that would make it phosphoric acid. So hopefully you are tracking with that one. Now let's use this process to do a few examples. Start with NF3. I've got nitrogen. It's the least electronegative. It goes in the center. Fluorine will never double bond. I would write that down. Fluorine doesn't double bond. And it's always a peripheral atom. Now, nitrogen brings 5 valence electrons. I have 3 fluorines at 7 each, so I've got 26 electrons to use. Now, I love doing this. It's so easy. Step 1, 2, 4, 6. Make your bonds. Okay? Step 2, I like to satisfy my central. If you learn to satisfy your peripherals, go for it. It'll work. So now I've used 8 electrons, and if I can do my algebra, I have 18 electrons left. So I like to go in a circle like this: 2, 4, 6, 8, 10, 12, 14, 16, 18. Now, the reason I like to do that is there are times when that's how you would find out that things double bond. And so it's nice to kind of spread them out evenly. Now, I don't know if you'll remember this, and it's going to seem random right now, but I'm going to use the letter A to represent my nitrogen, and the letter B, there's a variety of people. Sometimes people use AXE, not really anything magic about it. The B represents peripheral atoms, and I have 1 central. I have 3 peripherals for 3 fluorines. Don't look at the bonds, look at the atoms hanging off. And then I have 1 non-bonded pair. The X stands for that 1 non-bonded pair. Okay? And we're going to call that an AB3X structure. It'll help us do some memorizing later on. So just hold that thought for now, okay? All right, let's do another one. We've got SF6. Now, sulfur has to be the center, so sulfur is my central atom. There are 6 fluorines around this. We're going to, quote unquote, violate the octet rule. This is sometimes called an expanded octet. An expanded octet. Sulfur brings 6. I have 6 fluorines times 7. So that's 48 electrons. And the way it's set up, I have no choice. You didn't have to memorize it. I'll have no choice but to give sulfur extra electrons. Okay, so it actually has 12. It's an expanded octet. It violates the octet rule, so to speak. So I've used up 2, 4, 6, 8, 10, 12. So I have 6, 36 left. I'm going to make these a tiny bit smaller. And 2, 4, 6, 8, 10, 12, 14, 16. My squares are getting pretty awkward. 18. Da, 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 da. I happen to know this is going to make everybody happy. And there we go. There's 8 around all of them, and I've used my 48 electrons. Again, I'm going to use the letter A to represent the sulfur. The B represents the fluorines, the peripheral atoms, or it could be a peripheral cluster of atoms hanging off the center, and there's 6 of them, and I don't have any non-bonded pairs. Okay. All right, we have one more here, and then we'll stop this video, and that's going to be plenty long for this one, but I'd like to finish up where we are, but I need some room, so let me erase. We're going to have sulfur in the middle with 4 oxygens. Sulfur brings 6, each oxygen brings 6, so I've got 30 electrons, but this is sulfate, so I have to add 2 to the mix, so I have 32 electrons to use up. Make your bonds. 2, 4, 6, 8. Satisfy your central. Done. Satisfy peripherals. 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. Everything satisfied. I don't need to double and triple bond. We'll see that in our next videos. It's an ion, so I have to put brackets and a charge. Okay, it's enough for now. Until I see you, this is signing off.